G'day. An interesting part came across my desk the other day. Interesting because it's got a little bit of trickiness to it. Some of it is pretty straightforward. It's just a cutout there for a bit of relief, a couple of tapped holes there. But when you start thinking about these tines here and how to make them, then you start getting into a little bit of complexity. To make this part, I had to make up some parallels for the mill, so I'll also show you that. But there's an interesting little way of doing this. This is a piece of 5mm material, and I want to take this down to a smidge over 4. Now, unfortunately, the parallels I've got don't let me do that. So they'll either be underneath, well, that's the tallest one, it'll be underneath the top of the jaw. So I need to have these sticking out maybe 3mm more. So I need to make up a set of parallels. I've got for some strange reason, some 35x3 material, and that'll work nicely because I need a finished size of 33 across there. So I'll machine those up. There's nothing special about parallels except that they are parallel. You can use pretty much anything you like. Because these are the size of the jaws there, I'm going to use a little bit of key steel to just pop them up, in this case 3/16 of a millimetre, and that will allow me to just machine off the top surface there. In the past, because it's handy, I've used pieces of round rod. The only difficulty there, of course, is that the thing you're machining has to be wider than the height of the rod, otherwise the vice jaws will sit on that. But in this particular case, the keyway steel will do quite nicely, and I can take those down to 33. A couple of things on my quest to make up some temporary shims, and the only reason I say temporary is that they're made out of soft material, and so they won't keep their parallelness, their won't be intact for long, but they'll do what I want to do, and I'll probably keep them around the place and see how I go. I've machined off 3 sides. That's just a length, arbitrary 4 inches. That's the surface there. I've gone over with a little bit of emery on the edges there. I don't want a burr there because that might stop them seating properly when I go to machine this top surface. The top surface itself, I'm not sure how well that'll come out, but you can see there's 2 lines there, and that's a sign that this has been sheared rather than cut. So that's one reason why you'd want to machine it all over, is that edge is rather rough. You don't know, but if you ever see something like that on there, it probably means that something's gone through a guillotine. And for 3mm strip, and you can also see the rounded edge there, that's how they make it these days. So what I'm going to do is I'm going to put that into my vise like so, with the machined edges down on my bit of key seal. I've dropped one in there, pull that up. I've gone over and tried to make sure that's all good. I'm going to now knock these down into the vise as you do. One mistake that people new to this make is that they'll hammer away as hard as they can with their mallet, and then wonder why they don't get a parallel job. This is actually a dead blow hammer, but you don't want to hit so hard that this is going to spring back, because what happens, you hit hard enough, it bounces off the whatever you've got it on, right? So so that key doesn't move, that's hard up against that. I've seen people do this with strips of paper as well, just to try and make sure that this is all good. But yeah, all you need is basically some firm blows to knock that down against there without sort of running the risk of bouncing back. With a dead blow hammer, the risk isn't so great, but if you're just using a standard nylon hammer, a nylon mallet, you might find that you're bouncing up. So something to bear in mind when you're setting things up in a mill vise is just don't hit too hard. You just want it down hard enough that you can't wiggle what it is you're hitting onto. I generally snug the vise up, give it a few blows, snug it again, give it a few blows, just so that it's staying there. I've run a pass across here and back. It looks pretty good. Now, there are two ways I could do this. I could take this out of the vise now, measure those front, that side and that side, work out, what they're doing. Hopefully the measurements were the same, and I can say, well, right, I need to take off whatever much. The other possibility is using one of these things. This is a depth mic. This is a Mitutoyo metric one. I've also got an imperial one because unfortunately my lathe is metric. My mill is metric, but my lathe is imperial. So you need one of each. You can get these that'll just do 25 millimeters, but what this one does, and you can buy these. They're not rare or anything. Is that you can take out the rod and put in another one. And so in this way, one depth micrometer can read all the way from 0 up to around about 100 millimeters. In this particular case, so holding that down there, I've got 8.13 millimeters, which add 25 to that, 33.13, which is only 0.13 off my target amount. So I'll drop that down 0.1. I'm not going to get too worried about the 0.3 on the end there, and that will clean up nicely. I can then deburr that. Because I've done both of them like this, I know that they should be the same thing, so even if they are slightly off, they will be parallel. If I wanted to do this properly, I'd have to machine some stock down to almost the right size, harden it, put it on the grinder and all that sort of thing. But as I said, for temporary work, this will do quite nicely. Both this part and this part are black bar, just what I had sitting around the place. Because I was going to be machining it all over, I didn't think that it mattered too much. One thing you do have to be careful with though is that sometimes this can have a bit of a bow in it. And the other thing is that you want to try and machine evenly from both sides, because if there's stresses built up in the part and you take, the stresses will be greater near the skin. If you take off one side more than the other, you might tend to get it bowing a little bit. So you want to try and do this as evenly as you can. Now, I want this piece, this is about 5mm thick, I want this to be, I think it's a little bit over 4 eventually. Now, you can see there is a little bit of a bow there. This side is convex, and so therefore this side is concave. What I'm going to do is I'm going to set it up so that the convex side is up. I'm going to do a minimum cleanup on here, and then I can then flip it over and know that this surface should be, well, flat-ish, and I can clean that up and hopefully get my finished dimension. For those people wanting to know how I did with my shims here, my parallels, I'm 33.1, 33.1, 33.1 and 33.09, which I'm really happy with. On a good day with the wind behind me and all that sort of thing, I maintain this mill is probably good to 0.05 of a millimetre. So to get 0.01 I think is doing really well without any special preparation. If I wanted to get that last bit of accuracy, I'd have to make sure my cutter's very sharp. I'd have to make sure that the vise was absolutely parallel to the table here. I'd probably want to check what the feed was doing to make sure that I wasn't sort of feeding downhill or something like that. So I'm quite happy with those numbers. Any better than that, and I'd have to be doing a bit of grinding, I think. First clean-up pass, and you can see there's still a little bit of the black there. And on this side there's a small amount there too, but that'll give me a flat enough surface that I can then put that down and then take off the high spots there and there. Now this has to come down to 4.4. It's now 4.8 in the middle there, so I should be right with that. If you're machining up a piece of bright steel or something that's been machined before, you can achieve the same thing by just covering it with markout glue or with texture or something like that, because you'll see the bit of texture that's left, and that'll give you a gauge for the flatness. I also do that when I'm turning parts and I'm doing multiple passes to try and get out imperfections, or when I'm turning threads and trying to work out how to do how deep I'm going and where the original surface was, I'll also blue that up just to make sure that I can pick the difference between the stuff that I've just machined and the stuff that I machined maybe a pass ago or is unmachined if it's bright. So on this side I had basic cleanup. You'd probably say something like 90% cleanup there. On this, I then flipped that over, so I took the convex bit off and made it flat along there. I've then come along onto the concave side and taken off the high spots which were there. I think there's a 0.3 depth of cut there, and now I've got something there that I think looks pretty flat. So I'm now going to go back and come down. I've got 0.15, I think, of a millimetre of extra space. So I'm now going to come back and just sort of do another cut along here just to see if I can take out the edges in that spot there. And that way I should have a piece of material which is the size I want all along. And then I can actually start machining the part. This is the drawing that I'm working to. And this is where the planning of operations comes into it. There's a very shallow cut here, which is just for relief, and there's another one there for a bit more relief as part of this arrangement. So I'm going to start off by doing that. The actual cutting of this bit I'm going to leave till last, because as you can see, these bits here are pretty thin. They're not terribly wide at all, and they're only 2 millimeters thick. So I'm going to leave those until the very last, and I'm going to use a trick to get that shape. But first of all, I'm going to take off 0.4 off there, and I'm going to take off, 2.4 off this one, so that I get that profile. Okay. This bit here, I'm not too worried about. That's purely cosmetic, and these are just for a couple of M5 holes. So it's really how to accurately get this relief in, but how to accurately get that profile. Off the back of this, so on the underside here, I've machined off the 0.4, and that gives me a nice broad area that I can sit on the parallels and be flat. I'm now taking this down to 2 millimeters, and that's the line I'm going to there. And I've gone down to full depth simply because it gives me more support here. If I'd gone right up to here, at say, and took off say 1.6 millimeters or something like that, I'd have a comparatively flimsy piece of material sitting out here. By starting on the outboard end and machining it away in slices, I can make sure that where I'm doing the cut has got the full thickness of material for support. So here you can see the trick for forming these very thin parts. I've left a piece of material there. I've cut one out. I'm going to do the next one there, and then as a last operation, or one of the last operations, I'll come through and cut that off on that line there, and that'll give me the 3 fingers without having to worry about how do I hold that very narrow piece. So it's one of those things where you think about your setup. You don't necessarily cut everything exactly to size. You do your machining, and then you can trim things up and all that sort of stuff. These cutouts here I did just by drilling a hole down there and then cutting down to the hole, cleaning up with a file. So if you ever have to do that sort of thing, hole first, then file. So here's the final part. The last operation was to basically cut this piece off. I just hacksawed that off and then just dressed up the corners there with a file. This is actually how they make forks. When they make flatware, cheap forks, they make 2 forks together with a bridging piece, and then that last thing they do is cut that out, and that's how the tines stay together. So yes, interesting little part, interesting little trick to make it. Thanks for watching.